In this video, we want to talk about the ideal gas equation. According to Boyle's law says that the product of pressure and volume is constant. Charles' law says that the ratio of volume to absolute temperature is constant. And pressure law says that the ratio of pressure and temperature, or pressure to temperature, is constant. If we combine this, we're going to have PV, which is Boyle's law, over T. So here is V over T, here is PV, and that it is constant. We call this the general gas equation, which is P1 V1 over T1 is equal to P2 V2 over T2, the general gas equation. For an ideal gas equation, we can say that PV is equal to nRT. Of course, this is the pressure, this is the volume, this is the number of moles, and this is molar gas constant. Number of moles can also be written as mass over molar mass. Therefore, we can rewrite this as PV equal to, instead of writing N, we said mass over molar mass RT. So this is the molar gas constant, and it is equal to 0.082 atm dm cube per Kelvin per mole. So it is a constant. This question says, from the diagram below, an ideal gas is represented by this or this or this or this, and these are the options. Now, if we check from an ideal gas curve, when you plot the product of pressure and volume against pressure, this person A is hydrogen, this person B is nitrogen, this person C is CO2, then it is this person D that is the ideal gas. So let's solve this question. It says the number of moles of gas that occupies the cylinder of a bike, 30 dm cubed, at 5 atmosphere and 97 degrees Celsius is dash. This is the molar gas constant. So we want to find the number of moles, and they gave us the first volume, 30 dm cube, and pressure, 5 atmosphere, and temperature, which is 97 degrees Celsius, which is equal to 97 plus 273 to convert it to Kelvin. If we convert it to Kelvin, we get 370 Kelvin. So since PV is equal to nRT, therefore N becomes PV over RT. And if we put them, we have 5 times volume is 30 over R is 0.082 times T is 370. The top is going to give us 150, then the bottom will give us 30.34, and if we divide that, we get 4.944 approximately, which is option A. So let's also solve this question. It says 200 cm cube of a gas at 25 degrees Celsius exerts a pressure of 700 millimeter mercury. Calculate its pressure if its volume increases to 350 cm cube at 75 degrees Celsius. Now, the first thing we do is bring out the parameters. The first volume there is 200 cm cube, and the first temperature is 25 degrees Celsius, which is 25 plus 273, which will give us 298 Kelvin. Now the next thing is to continue. The first pressure is 700 millimeter mercury. Now we're asked to find the second pressure, and the second temperature is 75 degrees Celsius, which is 75 plus 273, and we add that, we get 348. Remember that P1 V1 over T1 is equal to P2 V2 over T2. Therefore, if we make P2 subject of the formula, we will have that P2 is P1 V1 T2 over V2 T1. So if we plug in the values, P1 will have 700 multiplied by 200 multiplied by 348, or divided by 350 multiplied by 298 Kelvin. So on top we'll have 487,200 over, down we'll have 104,300, and if we divide that, we have that P2 is 467.11 approximately millimeter mercury.